Hey everyone, Audrow here. Housing is expensive. A big and growing part of that expense is the cost of labor. People are expensive, and the labor force is shrinking as more people retire than join. A big way to drive the cost down is to automate parts of the process that are labor intensive. But robotics at its current state is only good at certain things. Therefore, there's an art in picking things to automate. If the task is too obvious, you have a ton of competitors and it becomes a race to the bottom. If you pick a task that's too hard, you run out of money trying to solve the problem and the company fails. Today, I'm talking with Barrett Ames, who's a co-founder of BotBuilt. I think that BotBuilt has found the sweet spot here. They solve a few really thorny problems and it lets them automate building wood frames for houses and other buildings. I think this conversation will be interesting to any aspiring entrepreneur as a great example of how different challenges can be overcome, people curious about robotics in construction, and any investors looking to learn more about a strong robotics company with what seems to me to be a strong moat. Before we dive in, a small secret since I'm making an announcement in a couple days, but I'm excited to share the Audrow Nash podcast jobs board. This jobs board grew out of a problem I kept seeing, robotics companies struggling to find talent and talented people struggling to find the right robotics opportunities. I hope this jobs board can be a help here. Several great companies are already posting positions, including this episode's guest, BotBuilt, along with Formic, Luxonis, and Rerun. BotBuilt is still finalizing their hiring plans and should have more engineering roles in the next couple of weeks. If you're looking for a job or maybe thinking about making a change, you can sign up for free email updates to be the first to know about new positions. If you're at a robotics company that's looking to hire new people, consider posting on the Audrow Nash podcast jobs board to gain visibility with our great robotics community. Postings are free. You can learn more at jobs.audrownashpodcast.com. I'll have a link in the show notes. All right, grab a snack, get comfortable, and here's my conversation with Barrett Ames. Hey Barrett, would you introduce yourself?
Yeah, my name's Barrett Ames. I'm one of the co-founders of BotBuilt. At BotBuilt, we build homes with robots.
Tell me more about that. What are you doing to help build homes with robots?
Yeah, so we do a bunch of construction in a warehouse, right? So somebody sends us a floor plan. That's just like a PDF drawing of the kind of house that they want. In fact, it doesn't even have to be a PDF anymore. We just literally did a napkin drawing. Like somebody drew out on a piece of paper, like, this is how I want my house to be. And we were able to design that from the piece of paper. But anyways, however you have it, you give us your floor plan design, your house design. We ingest that, design out the 3D aspects of it. So where does every piece of lumber, where does every nail go in order to build this house? That gets transitioned over to our robots. And we figure out first kind of the high level plan. How do we go and do each of these pieces? So where, do we put this piece of lumber in before that one? Do we put these nails in before those nails? We do that. And then we execute it on the robots. So that's, dealing with all of the gnarliness that is lumber, right? It'll be bowed, it'll be twisted, all sorts of bad lumber. And we do all of that in a warehouse in big chunks. Build your house over a period of time in the warehouse, stack it up on the back of a truck, ship it out to the job site. And the big win there is it lets the framers go, the rough carpenters that are on site, it lets them go from a 14 to 21 day build cycle down to 4 hours. Wow. So there's a big labor savings in particular on the job site, right? Which is just like job sites are like not a great place to be, right? Like you're out there in the cold, you're out there in the sun, you're out there in the heat. We just got our site video back from our last build, and one of our panels didn't make it because they tore it up and burned it to stay warm, right?
Oh my gosh.
Like that's
hilarious.
Yeah.
Oh man. Yeah. So you don't want to be out there. And this is specifically for the framing part, which is the walls that go up,
right?
Correct?
Correct. Yeah. So you can think about it as just like the bones of the house.
Okay. And so how is this done now? And then I'd love to hear about how you guys are doing it, and then the challenges you come into by doing it with robots.
Yeah. So right now it's all done by hand, right? It's just if you go out to the job site, there'll be like one really tattered piece of paper on every job site, and that's the floor plan. Every framer is going and looking at it, drawing on it, spilling their beer or their Monster on it, right? Like, and they're just picking up pieces of 2x4, cutting them down to size and nailing them together. And it's surprisingly dangerous, right? Like, you don't, you kind of think about it abstractly and you're like, oh yeah, you're just putting 2x4s together. Yeah, whatever. But in order to build the house up, right, like, you really have to start doing some pretty interesting gymnastics pretty early, right? So, like, on that site video that I was just referencing, we could see guys on other jobs standing on top of the first floor, walking around on 2x4s, right? That's all. No safety equipment. So it's just like there's saws everywhere, nail guns, and it's just generally not a safe place to be. So there,
I bet the accident rates are pretty high.
Yeah,
for this, and especially once you get into multi-stories,
right?
Because I mean, first floor, it's like, well, you have to stand up these things, and you have to cut, and you have nail guns and things like this. I'm sure accidents happen just on the first floor, but yeah, I'm sure with more than one floor, it becomes very dicey very quickly.
Yeah,
probably.
Yep. And so it's, the way that they do it right now is pretty rudimentary, right? It's just you get the plan, you build it, and then somebody else comes by and checks it, and that's kind of the end of the story. And you gotta do it in whatever weather there is.
Yeah, that stinks. Like hot or cold or anything.
Right.
But so I think there are some challenges, because we talked before, and so I remember some of the things. There's some challenges that sound very interesting with this. One, the floor plan is very low resolution. Like, it's just basically, this is where the walls are going to go. They're not saying the distance between the studs, how much wood they need, all sorts of things. So I think there's there's a lot of ambiguity in this, and especially for like custom homes or things like this, a lot of variation, and then probably a lot of waste because of this. Tell me a bit about this.
Yeah, so every floor plan, when you look at it first, you think like, oh, this is a technical document, right? Like, it's got lots of lines and there's like a scale, right? And like, there's all these dimensions drawn everywhere. And what we found is that it's not a technical document at all. It's actually just providing designer intent, right? Like, we want a window and the window is here. The door is there, right? And we understand it to be intent because, like, if you shift a door an eighth of an inch left or right,
no one cares,
right? They do care if all of the doors are lined up in a hallway or something, right? Like, so there are kind of these design guidelines. And so the first thing that we have to do is really bring all of that intent in and then go and design every little bit. And because we do that, we get a really accurate accounting, right? Like, we have to know where every nail goes in order for the robots to come and do that. And when they're building a house right now, they're literally just looking at a piece of paper and going, oh yeah, I need to do that over there. And they walk over there and do it, right? There's not a lot of there's not a lot of planning necessary. And so they don't do a lot of planning. And so when we go through and do every single stud and every single nail ahead of time, we get this really accurate picture of the house well before it gets built. And because of that, we can order material more accurately, drastically reducing waste, right? So on the houses that we've built, we've had our contract partners say, we usually have 3 to 5 dumpsters of waste. But with you, we only have half a dumpster of waste, right?
Damn,
so there's
a big reduction.
Big reduction in waste. And then on top of that, the way that they actually currently order materials is really interesting. They'll take the floor plan and they'll go to a lumber yard and they'll say like, hey, lumber yard, how much material do you want? Or do we want? And
that sounds cooked.
Right.
Yeah.
And so we've found 20 to
all of it.
Yeah. So we find we find 20 to 40% saving in material just by kind of solving this asymmetry in incentives.
Okay, that's very interesting. What about, so another problem that I see that's kind of difficult is the variation in wood quality. So like you buy a 2x4, it's slightly twisted or a little longer, or the angles are weird, or tell me a bit about that too, because that probably is a challenge also.
Yeah, it's a massive challenge, and it's a key challenge, right? There are a ton of grades of lumber out there. You can go all the way up to LSL, which is this beautiful engineered lumber, and it will be straight and perfect, but it costs 10 times as much as what a normal house is built with.
You're paying for that precision.
Right.
For this kind of thing, because it's too spec.
Right.
Okay.
Right. And so early on at BotBuilt, we had this decision put before us. Like, do we decide to engage with the lumber that is on the job site, or do we pick this much better engineered lumber? Right. And it would have made the engineering problem much, much easier. But we decided that the fundamental thing is that we need to build more houses in America. And that means cheaper, cheaper materials. So we went with what homes are built with today. And if you look at what homes are built with today, it's just the 2x4s that you can see at Home Depot, right? Like it's just going to be twisted and bowed. There's this thing called waning, which is where big chunks of the corners are missing. Right? There's going to be knots. There's a big pine beetle problem right now, so there'll be holes in some of the lumber. And that's okay, right? Like there's some amount
doesn't compromise the structural integrity that much.
Right.
Okay.
Right. And so there is just a ton of variation within one species of lumber, right? Like we in the Southeast build with what's called SPF, spruce pine fir. But if you go to the Pacific Northwest, they're going to be more Douglas fir. And so you'll get variations in all sorts of the texture, like the visual texture, but then also the geometry of the 2x4 that are species dependent, location dependent, harvest dependent, time, like how old was this tree when they chopped it down? All of that leads to just an immense amount of variation.
I bet. Okay, so how do your... So like I feel like I have a good grasp of the problem now. How do your systems work, and what have been kind of the hard problems on the way? I can imagine a few, and we've talked earlier, but tell me about kind of like end to end. What are you guys doing? I know you're building the frames, but what does it look like in your operation? And then I'd love to just quickly, as you're describing it, talk about the hard problems, and then we'll dive more into each of them.
Yeah, from an operational standpoint, right, like working with lumber starts at like a really material handling specific level, right? A lot of approaches don't think about just the logistics of moving a 2x4 around. And so what we do is we just stack all of our lumber right next to the robots. And then the robots look over, grab the piece of lumber out of it's called a bunk, which is just a big old thing of lumber, right? Just think about all the lumber that you see stacked up in Home Depot. That's a bunk. We grab a piece out of that. We put it in a measurement device at the back of our system that allows us to position it precisely to a 32nd of an inch. Then we pick up a saw, cut the lumber down to size, and then pick it up out of our we call it the input table, but basically our measurement device, and put it on the work table. You do that a couple thousand times, and you've built a house, right?
Yeah. Okay. So you process the lumber, you put it in a big bin, the bunk. You grab it out, you cut it, you place it where you need it. How do you? I guess so. The main challenges that I see with this, one, getting an accurate 3D model of all the wood, and then doing something appropriate with it to cut it and things like this. Like, tell me a little bit about that. I suspect that's a good challenge. But...
Yeah. So actually, even before we characterize the lumber, just the bunk actually comes to us just strapped, right? So there's like
that's nice
14 by 14 grid of lumber. And when we cut the straps, It's a bunch of lumber all recently cut from the same tree, all laid out next to each other. So actually, like, key first problem is individuating or singulating that piece of lumber
I bet.
visually, right? And so there's actually a really interesting challenge there that we solve with a deep convolutional neural network and a whole bunch of data that only we have, right? Like, there's not a whole lot of people out there that are collecting mass amounts of 2x4 data, but we're one of them.
Yeah.
And so
That's funny.
Yeah, we singulate each of them just using a stereo pair, and then pick it up. We pick it up using vacuum grippers.
Wow.
Yeah.
I'm impressed it's vacuum grippers for that. That must be a big arm and big vacuum grippers then. How heavy is each of these pieces of wood?
2x4 is actually only 10 pounds, so they're actually pretty light. And
just awkward and long.
Yeah. It's like a motion planning nightmare, right? Like, just imagine
you don't want to whack stuff.
Right. Yeah. Just imagine everything's a bug trap problem, because that's what everything turns into when you have this long piece
What is a bug trap problem?
Oh, yeah. Just like, it comes from the bug traps that you'd use to catch, like, fruit flies, right? Like, you take a cup, you put some vinegar and some sugar in the bottom of it, and then you put some saran wrap over it and you poke a hole in it, right?
Okay.
And the fruit fly flies into it, but it's they're too dumb to get out. Like, there's just one very narrow passage that can get through. That's what in motion planning, like, that's how we describe kind of these narrow passages, right? Where relatively easy to get in one direction, but, like, very specific to get out the other direction.
To pull it out of the bunk for this kind of thing.
Right.
Okay.
And so just moving with lumber in general kind of turns everything into these narrow passage problems.
For sure.
Right? Because you
have to, like, put it this way, then bring it that way.
Right.
Like backing up a car, kind of like K-turn the wood.
Right.
This kind of thing.
Right.
Okay. So you have to move all that. That sounds painful. Or it sounds like a challenging motion planning problem, and segmenting it from all the other wood that looks similar with a 3D sensor.
Yep.
That sounds hard.
Yep.
But so you have a data set for that you've collected through your own means.
Yep.
And that lets you do it. Okay. So that's kind of like problem one is the segmenting it.
Yep.
So problem two is moving it.
Yep.
Then you move it to your saw and your position for measuring it and everything.
Right. And that's a really tricky problem as well, because gripping onto lumber is actually pretty soft, right? And so you have to worry about deforming it while you're moving it, and how that impacts your measurement. And so there's a bunch of how do we move it really quickly, because we need to move it really quickly in order to process it in an economical way. And get it down to a 32nd of an inch, right? So we have to measure very precisely to really get the tolerances we need, right? And those tolerances are basically driven from, like, how the lumber stacks up in a building. And so there's, like, a really interesting controls problem there that we tackle with some in-house kind of combination of controls, sensor fusion, and some custom mechanisms.
Gotcha. So once you're grabbing the wood and then you're placing it, measuring it, cutting it, this kind of thing. Now there's still the difficulty in my head of going from the napkin sketch to the full plan that has, like, windows and doors and all the features that one might expect and matches code and things like this. Tell me a bit about that, because that sounds hard and interesting also.
Yeah. So that very difficult problem, and just absolutely key to getting everything working in the right direction, right? And so what we do is kind of this combination of mixed integer programming and generative AI, right? So we need to take in all of these constraints and generate the true constraint, right? And so we use a generative model.
What is your true constraint? What do you mean?
Well, like, we have to interpret all of these as an intent. as opposed to like a mathematically true
a fixed dictum,
right?
Yeah,
And so that's kind of that's the translation that I'm talking about here.
I see. Yeah, so there will be a true constraint, and that is something that matches all of the specifications dictated in the. Okay, so you have to interpret that into something that's like complete, in a sense,
And so, in order to build that model, we actually have just over 2 million square feet of floor plans that we've now processed, and that lets us train. I think we've got we've got 4 generative models now that are built off of that, just picking out all of these different constraints and synthesizing them together to give us something that can go into the optimization. Right.
Okay. Why 4 models? What are they each doing differently?
Well, we kind of segmented it up into different problems, like finding windows and doors, as opposed to dimensions. And like there's just some nice areas to segment it up.
I see.
Yeah.
Okay, tell me more about that, because that's very interesting. So you trained on a bunch of floor plan data. What did that data look like, and where were your sources for that?
Yeah, our sources mostly come from builders that we've been able to talk to, and it's just anyone and everyone that we can get to give us a floor plan. We'll use the data to help train our models.
Okay. And then, so do you have to annotate it initially, or how did all that work?
Yeah, so we've got a labeling team that goes and annotates. Really difficult to outsource that because
I bet
it's not your standard like labeling problem, right? It's not just a classification problem. It's I mean, in some parts it is, but there's just a lot of context.
Well, you need to be sort of subject experts in some sense. Like you need some training.
Right.
So I'm sure you can't like Amazon Turk or whatever it is, that thing where you have like random people do your task for a few cents or whatever it might be.
Right. Yeah. So we spent 6 months training up a labeling team to be able to read construction plans and go and label everything. And they're very key to the beginning of the whole process, right? Like without them, we wouldn't have been able to get to this point where now they're more supervisors, right? They're doing a lot of validation. And the models are doing most of the work. But early on, they were providing all of the annotations for it.
That's cool. Okay, so you have a bunch of floor plan data.
Yep.
You use that to learn how to generate plans that your robots can make. You've had a bunch of people bootstrap this by adding the data in, and then you learn from that. That just sounds hard to me. Like I wouldn't naively know that would be a tractable problem in a sense, or that the data wouldn't be just like total garbage. The output wouldn't be total garbage for this kind of thing. Like how do you, like it seems like an optimistic bet to me, and I'm glad that it seems like it's working. But tell me a bit more about the challenges around there.
Yeah, I think, first of all, you're not alone, right? Basically, every engineer that I've talked to about this problem has been like, well, why did you even solve this problem, right? Like, can't we just make architects build it in CAD, right?
Sounds expensive and slow.
Right. And the fact of the matter is that most PDFs most homes are coming out of designs that already exist, and 99% of them exist in paper. So that really provided the impetus for going and building this thing. And it's really this combination of our like ripping out all the information or extracting all of the information from the PDF with our optimization, that makes it all work, right? Because, there's this feedback cycle of, here's everything that we've learned from the plan. All right, run it through the more procedural optimization constrained approach, right? And the way that we built that optimization is really important because it can. We knew up front that builders were going to have different ways of building things. We knew that every state you go to is going to have different building codes, and so we had to build that optimization in like a very, very nice way
to include those features.
Right.
Or like labels or something so that you can use them. It's like, so your model understands the differences that it may be seeing. Do this with the constraint of 16 inches between studs.
Right.
I'm making it up, but like something like that, where one place might be 18 inches or something like that. 10-foot walls versus 8-foot walls versus whatever.
Right. And that's why we went with like a more classical optimization approach there, because we can just swap in and out the constraints. And those give us like these hard guarantees that we're going to satisfy the building code, even though we're shoving in a whole bunch of stuff up front. And if if the labels are wrong or the annotation's wrong, which at this point like they're like 99%, which is pretty good.
That's exciting.
Right? Yeah, it's great.
Oh, totally. And then hopefully if they're 99%, that 1% is just like a little tweaking, or you run it again or something.
Right. So like the first time we built a plan, I went through, we didn't know that we needed this software, right? I went through the plan and designed every single panel by hand, right?
Yeah.
And like that took me a week.
Wow.
And then I was like, this is nuts. I should find somebody else to do this. So I went and asked a civil engineering firm, like, hey, will you guys design panels for us? They gave me a quote for $20,000.
Wow.
I was like, all right, so we need to build this software. And now we're down to just under 2 hours with validation. Right. And the goal is 30 seconds. I want to be able to put a plan in, get a quote out while you're on the phone with someone.
Oh, that would be so sick. Hell yeah. What is it? Do you have any idea about the cost reduction in that? So if they quoted you at $20,000, this probably, if you don't include all the R&D cost and time developing it, your run cost is probably like super cheap.
Yeah,
like
our run
$1
or
a few dollars.
Yeah, our run cost with validation is about $20.
That's amazing.
Yep.
So 1,000
reduction. Yep.
That's bonkers. That's so fun.
Yeah.
That's beautiful.
Yeah.
Hell yeah.
Yeah.
I love it.
Yeah, it's like one of the key driving things here, right?
Yeah, big differentiator, I imagine too, because it sounds like a thorny problem, and it sounds like, so when you say generative solutions, you're not talking like ChatGPT, generative AI.
No.
You're talking more like classical optimization where you put in constraints. What is it?
Well, like
evolutionary strategies.
No.
What kind of things?
When I mean generative, I really do mean generative. Like
it's generating something.
Like there is an underlying distribution, and we're learning that underlying distribution. And you can think about new things coming in and then sampling from that distribution. So you can kind of condition your distribution based on information that you've brought in.
I see.
And then sampling from that to give you an idea of confidence in something, right? And so if you make a bunch of samples and they're all the same thing, you should have pretty high confidence. Like, oh yeah, this
totally
right. So it's that's when I say generative, I do mean like
literally generative.
Right,
you're making a distribution, you're sampling from it.
Right.
I see. With that, what kinds of decisions is the model making? Like, what all is it deciding?
It's it's
like stud placement or like configuration of wood when you're putting like an AC duct somewhere, or like all these things. Like what all is it deciding?
Yeah, it's really synthesizing all of the various constraints, right? So it's like, what's the given window placement here and dimensions here, like what where do we really want that window? And so it's taking all of that.
Hell yeah. And then so you're getting a higher fidelity model with all the studs and things like this in their position.
Yep.
How do you go from there to what your robots are building?
Yeah. Great question. It's deeply technical question. But at a high level, like we're just thinking about the geometry of the robot, the geometry of the problem, putting those two together, and saying, all right, we need this 2x4 to go here. How does that impact what the robot can do, and vice versa? It's the way that we've implemented it very much falls in line with an area in robotics called task and motion planning. And specifically, like, a lot of the details are just stuff that come directly from my PhD. So I did a lot of work on how do you do this kind of high level task planning, but it's parameterized by some behavior that the robot has. And so that
what do you mean? I don't quite understand. Parameterize. So task, I think of, so you have something to do that requires many steps. And then parameterized with it by the behavior that the robot has. I don't quite understand.
Sorry, I kind of got my words flipped there. The behaviors are parameterized in the sense that, like, you know, if you want to put a 2x4 on the table, there's a whole bunch of spots on the table you could put it down.
Oh, of
you
course.
need to figure out what where on the table is it going to go.
Yep. So your parameters are dictating what to do next. So you have a bunch of simple behaviors like place the thing here, but then you have the parameters that specify the wood should go in this location and then another piece should go in that location for this kind of thing. So you break down, but so that the process of breaking down your output from the blueprint to, like, PDF to a more detailed frame design, that part's very interesting, and maybe that's very hard to talk about for this kind of thing.
Yeah,
but I'm curious about that because I imagine you have to figure out where all the nails go. You have to figure out what order tasks must be done.
Yep.
Like, there's a lot there that I imagine is very hard, and the way that I would naively suspect you implemented it is a bunch of heuristics have been specified, and then you kind of run it over this. Like, basically, make sure you have something placed so you can attach something to it. Nails go every this often, this kind of thing. But tell me how you've done that.
Yeah, so at a design point, right, like at the end of the floor plan to design stage, we end up with just a CAD of the house, right?
It's so cool.
It has every 2x4, every nail. And so from that, we can take a panel out, right? Like, take our Lego block of the house out of the house and say, all right, we want to build this chunk. And building that chunk is really just a planning problem, right? We know what our end goal is, and we know a bunch of initial conditions, which are we know we have lumber, and we know where nails come from. Right?
Yeah.
They
I like your framing of this.
Right.
Yeah.
And then we have a
you say go.
Right. We have a classical planner that interacts with the geometry of the robot and searches through that space to find, you know, given our set of behaviors and the parameters for those behaviors, how do we get from pile of lumber and the ability to magically make nails appear to end panel?
That's awesome. And do you kind of go through it in simulation first?
Yeah. So
how does all that work?
Yeah, we do it all first in simulation to figure out, like, what's the feasible path, right?
Yep. Because that sounds very hard.
Right. And feasible path, we get in about like a minute and a half to 2 minutes. Then we spend like another 25 minutes optimizing. And then once we have that optimized path, it's giving us like high level behaviors and their parameters, right? So it's put down this 2x4, which for us is almost always the top plate goes in first. Top plate's the 2x4 that goes at the top of the wall, and then you put down a bunch of studs, and then you put down the bottom plate. And how you put the order in which you put all of those studs down is very important, because the geometry of our end effector, like,
can't get everywhere,
right? Unless you put it in just the right order. And so we figure out that order just by simulating everything, right?
I would imagine. Okay, that's really cool. And you basically, is it like you're trying to simulate it forward, and then it's like, oh, blocked, and then you throw out that one and you generate again, and you do that a few times? Or how do you, or it's an optimization problem where you keep moving? I'm curious how you frame the optimization problem to get the targets, I suppose, or like the the path that you're going to end up doing for everything.
Yeah. So because we know what we want at the end, and we know everything that we have, both material and behavior wise, right? We can, in parallel, look at a whole bunch of different configurations that we might run into along the way and decide whether or not they're valid. And that's a really fast simulation check.
Oh, that's cool.
And so it just shunts off whole branches of the planning problem really quickly.
Yeah, so it's a big branching thing, and you keep going, oh, this one doesn't work. Right. Cut that off, and then keep proceeding down other ones. And so you'll have this big explored space of possible solutions. And then from there, maybe that's where your like 25-minute optimizing occurs. Where you're like trying them, scoring them, whatever it is.
Right. Yeah. Because the first plan through, it'll like pick up and put down the tool like 25 times or something silly like that, right? Because it's just doing like a depth first search through this massive,
huge space.
Right. Right.
That's wild. What a cool thing. Okay. Hell yeah. So then you assemble your pallet and you load it on a truck and then ship it out, and then builders assemble it. That's awesome. Okay. So how do you handle exceptions with this? Like, I'm sure that things don't go right all the time.
Yeah.
Like maybe sometimes you drop a piece of wood or a nail doesn't go in the correct spot. They probably go in the correct spot, but like say it chips the wood or something. Like I'm sure exceptions happen.
Oh yeah.
What are some of the exceptions, and how do you deal with that kind of thing?
Yeah. So the exceptions are they are exceptional, but not as exceptional as I would like, right?
Of course.
There's, if you think about a house being 1,000 pieces of lumber and 2,000 joints, there's going to be like, we have to be really, really good in order for there to be no errors. And so what we do is actually pretty interesting, and I've never seen anybody in robotics do this. I hope I'm wrong, and there are just smarter people out there. But we use this thing called the Good Turing estimator. So Ian Good was one of Alan Turing's colleagues while they were building the Enigma machine, and he developed this estimator that just allows you to estimate the number of unseen bugs. Right. Really useful, interesting tool. And it's actually how we quantify our exceptions, even though we haven't seen all of them. So we just write them down as we see them. There's a few kind of key hot spots, and then there's a long tail of stuff. And that's one of the really, really key things to construction, is that there's not one big, like, hairy problem. It's a
bunch of little ones,
1,000 little ones.
Yeah, totally.
And so I actually, early on, I was really lucky to find this guy who I consider to be the oracle for the problem that BotBuilt is solving. He spent the first part of his career as a CB in the Navy, so he was building stuff. And then when he left the Navy, he went from a laborer to a superintendent of construction. And then just, around then he was like 40, 45 and decided like, I don't want to do this anymore. Robots are cool. I'm going to go build robots. And did all the way up through the DARPA Grand Challenge, right? So he has a vehicle entered in the DARPA Grand Challenge. Like, just awesome. Just like, how do you find people like this? I don't know. I just got really lucky and found this one dude. And so
our world's amazing,
right? I invited him out to BotBuilt and I said, like, look, how do we die? And his advice was exactly what I just said. The construction, there's not one big problem that kills you. It's not doing the 1,000 things well. And so that's how we're always trying to figure out what are the 1,000 things, and then how do we prioritize those 1,000 things to do well? Because we're constrained, right? Like, we can't solve them all at once. So like the big things for us over the last couple of months have been taking out those really high frequency things, like the computer vision singulating all of the lumber and doing it to a high enough of a degree. Those kinds of errors are actually pretty nice in that when we do have a problem in labeling, We just have an image, and we just need it labeled. So that we can actually just ship out, get it labeled, comes back, robots keep going, and now we have more labeled data. That's like super nice problem.
For sure. Yeah, computer vision problems tend to be nice.
Right.
A lot of times if you get them.
Right.
Okay.
But other other classes of problem are like we have this unobservable problem that happens about like once every 5 or 6 homes. A nail will go into a piece of lumber and there's a knot hidden beneath the face of the lumber. And so the nail will actually hit the knot, curve down around it because the knot's more dense, right?
It's harder,
right.
yeah.
And it'll actually go down into our work table.
So then it gets stuck.
And then it's stuck.
On your work
and
table?
we have no way, like the first time it happened, we were like trying to pull this panel up off the table.
Like, what happened?
Right. And then we figured it out. So that's just like an exception that we have to sense, right? Like, oh, we're trying to pull this thing up and it's not coming up. But we really don't have a great way of solving that one yet.
Can you put everything on like a not hard surface? Like I'm thinking like a spongy thing, but you may also want the rigidity for your framing. So that's actually probably pretty hard.
Yeah. It's definitely an interesting problem. I think we haven't even really tried to tackle it yet because it's so low frequency. But if I had to guess, we'd use the force torque sensors in the wrist and we'd notice like, oh, hey,
you can tell
we can't pull this up. But there is like when I pull it up, you can feel that there's like this direction that it wants to go. And if you just allowed it to kind of follow along that path, you might be able to pull it up that way. But
interesting. What a funny thing that the notches are harder.
Yeah.
And then you get the nail deforming for all of this. What a crazy thing. That's so funny. You're like, why the hell is this nailed to the table? It's like,
yeah.
It's wild. Okay. Any other classes of different exceptions you've kind of run across?
Yeah, we see constrained motion planning problems a lot, right? Like that's just a fundamentally difficult field still. Right? Like you're trying to sample from this manifold in 7-dimensional space, but it's a zero volume manifold from the sampler's standpoint. That's just difficult.
Super hard.
And we've made some improvements there. And it's all driven around the fact that we have to move these big pieces of lumber in very specific ways sometimes.
Okay, very interesting. So for the end result, how does this compare? Like, how many houses have you done so far, and how does it compare to the traditional building method of like the people on site building it?
Yeah. So we're just finishing up 27. So
27 houses?
Yeah,
or what's
27 houses.
That's awesome.
Yeah, and there are just people living in them, right? Like
that's wild. What I bet that feels good.
Yeah, it's great. I mean, there's nothing like writing code and then somebody lives inside your code, right? Like that's definitely a lot more like substance to that. It's pretty cool. And they don't know that they're robot built, right? Like it's just another home.
Yeah, they're just homes.
Right?
It's great. So how does it compare to, so you have 27 homes. That's super exciting.
Yep.
How does it compare in like efficiency or cost or things to when you're building it on site?
Yeah. So the robots are slower right now, but more cost effective because one person can monitor a whole bunch of them, right? And
It's like the grocery store thing where you have one checkout person manning 10 kiosks or something like this.
Exactly. So our kiosk checker, his name is Tim. Tim used to work at Chick-fil-A. He's just one of the guys' sons. He's 16.
Nice.
And
that's so good. Hell yeah.
He can operate all of the robots. right? And
What a cool job for a 16-year-old.
Yeah. It's he loves it, and we love having him because he pushes it way harder and faster than I will, right? Like I know too much.
He's 16, of
right?
course.
Like he'll just go for it. And so it's
like any good 16-year-old should.
Right.
So that's awesome.
Exactly. So we he can run all the robots. And that's where we get a lot of our efficiency, is just scaling out Tim's ability to build a whole bunch of panels at once.
Nice.
Yeah.
And that's awesome too, Tim being 16. So I suppose like maybe he has some construction background, but like that's exciting that it's someone who's like relatively new to the workforce.
Right.
And it's a good model for that kind of thing. That probably is very favorable for you guys scaling eventually.
Yeah.
That Tim can be
right.
Manning all these machines.
Right. Yeah. My co-founder Brent was in the Army, and he said that I had to make the robots army proof. Right. So like you just have to be able to have any old infantry be able to run it. And that's what we've tried to do.
That's hilarious. Yeah, one of my good friends is in the Navy, and he says the same thing, but Navy proof,
right,
for this kind of thing.
Right.
Hilarious. Okay, hell yeah. Do you have any idea? So with this parallelization, do you have any idea in terms of like time or cost, how it compares?
Yeah, we're still getting better numbers on all of those.
And maybe the trajectory of your improvements would be interesting to mention too.
Yeah, the trajectory has been pretty awesome. A year ago to now, we've improved our throughput by 5x. So
that's sick.
Yeah, big improvements there.
In throughput, is that correct?
Yeah. Yep.
Okay.
Yep. And we're about to drop a big feature that's going to double our speed. So that'll be awesome as well.
Damn. So it'll be 10 times better than it was a year ago, roughly.
Yeah.
I like that.
Yeah.
That growth curve.
Right.
That's awesome.
Right. Yeah. That's the kind of growth curve you need for a venture-backed company, right?
Mm-hmm.
Yeah. So, and then the other big wins that we see are that our panels are like frankly beautiful, in that they're very precisely made. And put together. We were just walking one of them recently with an inspector here in Durham, and he said, "Wow, this is like the best framing that I have seen in Durham." Right, which like feels really good, but totally. It also just means that at the end of the day, the consumer's getting a better product, and it actually takes significantly less time to inspect. Right, so. We've seen inspection times drop from 2.5 to 3 hours down to 30 to 45 minutes.
That's awesome.
Because the inspectors just gain a lot more trust a lot more quickly.
Now, not to like, I'm sure that's true, but to play devil's advocate, with like ChatGPT and things, they can seem very sophisticated, and it's kind of easy to trust for a lot of things, but there is definitely cases where they like will just hallucinate random stuff. And so the trust can occasionally be betrayed in some sense, or just it wasn't well founded.
Right.
This sounds a lot more structured than that. But how would you think about that kind of thing if there is kind of a downside to decreasing increasing the trust so much that they just let you go unpassed or unaccosted if something is a little bit wrong, because they were just like, yeah, everything looks so good, because they assume a high level of competence for the builders that are the machines, but you still can do something wonky somewhere and they just may not see it. How would you think about that kind of thing?
Yeah, that's an interesting question.
And obviously it's like, you're on your way to doing very good work.
Right.
So in the path of doing good work, you'll come, like, you're on the right path for sure.
Right.
But this may be a thing that,
one
could occur.
Yeah. So one thing, like they're just pattern matching, right? Like when they look through a house, they're just kind of looking for things that are odd and out of place. And our stuff tends to be extremely regular.
Orderly.
Right. And
so they're looking for exceptions.
Right.
And you don't have many exceptions.
Right.
That's exciting.
Right.
Hell yeah.
Right. And so that gives them the confidence. But it is a human inspection process, right? From the building inspector standpoint. We actually do QA internally as well, right? So because we have this 3D model of what we expect to build, we can,
and you vetted against that,
right? We can just look at that, and so that gives us a higher confidence. And I think, I'm not positive yet, but I think it will also help with insurance matters down the road.
That's super cool.
Like building insurance is kind of this really messy place. Like, a wall falls down and all the contractors just go, not me. And then the judge just gives everybody an equal share. And because we capture so much data on every joint and every piece of lumber, we'll be able to very clearly say, like, look, we did our part. And if we messed up, like, we'll also be able to say, like, very clearly, like, that's our bad.
Yeah, because you have like a 3D camera and you have like a camera image,
right,
and probably a 3D scan of everything. And so they could be like, this wasn't done right. And it's like, well, leaving our facility, here's the thing. It was perfect.
Right.
Which, I view that as a big win for insurance.
Yep.
For sure.
Yep.
It's so interesting to me that a lot of these automation, a lot of the output or a result of increasing automation is better monitoring. And that it's very interesting to me that like insurance seems to be a big winner through this because, and just like business tracking and things like you've mentioned, like inventory tracking and things. Very interesting.
Yeah, I think, so I've been thinking about this like framework or paradigm for like how to build robots, right? And what I call it teleoperation driven development. And the idea is basically like, first you have to design the mechanism, then you have to run the mechanism, but you want to run it with teleoperation. And that helps you get this idea.
Problem fit.
Right. Like problem fit, but also like you have to have really good perception in order to teleoperate it. Right. And so you get this like observability from a control standpoint very early in the process. And because we're building control algorithms that are subhuman, they always seem to need more perception than humans, right? Like they can't keep this internal.
What do you mean subhuman?
Just like below human capability.
They're not as sophisticated as us,
right?
I guess.
Yeah.
Or they may be in other ways, but for the most part, they're less sophisticated than us.
Right.
In sensing, say.
Right. Well, and kind of like keeping an internal model, right? Like we kind of sub out a lot of our perception for like this really rich internal model. At least I think. I don't know. I'm not a neuroscientist, but
that sounds right to me.
Yeah. And then, once you've done the teleoperation stuff, you've now guaranteed kind of two things. One, that you have enough perception, and two, that you have enough actuation to get the job done. Then you can go and build your control algorithm.
I like that. Yeah, I've been thinking of one thing through all these interviews that I've seen as a big pattern, and something that I've often said, I suppose, is like a human in the loop development is very good for startups for the reasons you described, but also like you can gradually automate parts of it. You're getting data, you're checking for unknown unknowns because you're actually getting out there and solving it. And using TIM or similar people where it's like you can slowly scale the number of robots one person is able to manage, then eventually you can get to full autonomy.
Right.
And at the same time, you're proving your market,
right,
which is really effective so that you can go get investment and you can go start working with and pleasing customers for this kind of thing. So they seem very similar, these two ideas. And I really like your perspective on it, where you have enough sensing and then you can confirm that the actuation can do it. So now you can start automating for this.
Right. Yeah. That's your thought process there. I think exactly mirrors kind of how I think about teleoperation driven development.
Yeah. And it's so interesting to me because a lot of the like hardcore roboticists don't like this approach, but it is, I think, a very fast way to find value.
Right.
Like where you can add value.
Yep.
And to me, that's more interesting.
Yeah,
to make something really work well.
It also really
and solve something.
Yeah.
Go ahead.
I was just gonna say it also really helps you quantify the problems to solve, right? Like
Totally.
the good Turing test that we do just really helps us figure out like, okay, these are the things with high frequency and high severity. Those are the things that are worth solving. Right.
It's a good way of weighting the problems to solve,
right,
for sure.
Right.
Yeah, because frequency times severity is the urgency.
Right.
Say.
Right.
I don't know that thing, but I'm gonna look at Turing and good. That seems like a wonderful.
Yeah, it's a
model.
It's a pretty interesting way to think about how robust your system should be. The other thing that I've done kind of with it is I've applied it to scheduling, which is pretty interesting as well.
What do you mean? Scheduling what?
Like engineering scheduling. So if you have if you've got some big engineering tests that you want to do, you get a whole bunch of engineers together. You all kind of lay out the path that you want to do, and the areas where like there's
highest technical risk,
right,
kind of thing.
Those will show up as like a whole bunch of different ways of doing the same thing. And where people are in agreement, it kind of collapses down to like one thing. And the cool thing about...
So that's the frequency
right.
Dimension is the consensus.
Right.
Interesting.
And so the cool thing that you get out of the good Turing estimation is you get, now instead of just saying like, hey, 2x the schedule, you get to scale your schedule estimate based off of uncertainty.
I love that.
And so the awesome thing that we were able to do with it was I took a 6-month project. We laid it out with this, and we were within a week.
Damn. That's awesome. Yeah, it's like how a GPS will take into it, like when you're taking directions on a map, it'll take into account all the uncertainty, but by the distributions of how traffic progresses and whatever, on average, you'll arrive pretty close to the time you wanted.
Right.
That sounds super cool if you could do that with engineering effort, because that's like everything is always happening later than it was expected and things like this. And it's interesting if you can codify your problem in this way and then get a really good estimate that takes into account a lot of the uncertainty.
Yep.
Super cool.
Yeah, it's been fun. I'm still experimenting with it, but at least the early tests I've done with it, it seems really helpful.
I would absolutely love if you make like a blog post or a video or something once you have it more fleshed out.
Yeah.
Or just hell, we can do another podcast interview.
Yeah.
And I would love to learn more about that, because that's a hard problem.
Yes.
And I mean, people do, or companies do Scrum and stuff like this, and not that satisfying in my experience.
Right.
And this kind of uncertainty, because I think that's always funny with Scrum is it's like, well, I don't know the task, so therefore it's hard to estimate. For this kind of thing.
Right.
And so this is like, it takes into account the uncertainty, which is quite cool.
Right. Yep.
Very cool. Do you have any idea of the potential I know I keep asking around the same kind of things, but I'm wondering, like, do you think it'll be a good bit faster? Because like one of the things that comes to my mind through most of my interviews is that there are massive labor shortages. And I think construction is one of those areas particularly strongly affected.
Yep.
And so I wonder how, like, just getting the task done at all is fantastic. But if it's done really efficiently and you make a lot of gains in terms of speed and it allows people to, you said 4 hours instead of 20 days or whatever you said at the beginning.
Yep.
Maybe that's the good metric to assess. I'm curious, kind of like an apples to apples in terms of like you build a house this way and you build a house the traditional way. I'm curious if there's like a cost estimate and then a person time estimate, and maybe the 20 weeks to other one. But can you talk a little bit to this? And it sounds like the trajectory is improving rapidly.
Right.
But I'd be interested to hear where you are and where you think it's going.
Yeah, we're right at parity right now. Like, it depends a little bit on the complexity of the job, but we're like up and down right around parity with human cost.
That's exciting.
And so I think, we still haven't turned the dial up on the actual industrial arms, right? Like, they're still set at 20% speed. So we can certainly get a lot more speed out there. And the the big thing that we're releasing shortly will be will help improve speed even more.
Can you speak to that at all, or is that a secret thing that will be announced eventually?
But just stay tuned. It'll be a pretty cool video. And I'll
oh hell yeah!
So we'll show it for sure. But yeah, there's a lot of efficiency still to be squeezed out. And we're making good progress on that every day.
Yep. So cost is about the same. And so if you make it faster, that'll make it cost less,
Yep.
I suppose,
Yep.
with all of this. And I mean, you guys, so you guys are approaching Series A.
Yep.
Correct?
Yeah. We're just about to do our Series A fundraise.
Hell yeah. Want to share any details with that, or?
Yeah, we're always looking for investors who are interested or experienced in robotics. There's, I think an ever-growing group of people out there who
It is growing, yeah.
who understand. I call it the return profile, but like it's the moats are much bigger in robotics.
Totally.
And so I think the long-term returns will be higher, but it does take longer, right? Like there's I can't ask ChatGPT to build me robot code yet.
Well, you can.
Yeah. But it's not it's certainly not as easy as building a web app now.
Definitely.
Yeah.
Mm-hmm. Yeah, there's a new breed of investor I'm seeing that's coming out that's thinking long term for robotics,
Right.
and it's very exciting to see. And they understand a lot of the grievances that robotics companies have had in the last 10 years, working with investors that try to turn everything into software as a service,
Right.
with subscription models and stuff.
And I think as a community, we're also just doing a better job of getting to value faster, right? Like
Totally.
doing this teleoperation driven development type approach, like lets us provide and verify value much, much earlier. Whereas, I totally used to think this way that like, yeah, we just got to automate the whole thing. But that's clearly the wrong way to go about building a robotics startup, right? Like,
yeah, not very capital efficient at all for this.
Right. So I think, the kind of investor community pairing, I think is really close to being I kind of think about it as like getting ever closer to like 2008, 2009, like web dev
For SaaS.
right? Where you're like, Ruby on Rails is just starting to come out. People are like, oh yeah, I can build all these cool things now. And yeah, I think the category as a whole is about to have an inflection point.
I think that's true. And I think that is going to be brought on even more by labor shortages.
Yes.
And like aging demographics causing labor shortages.
Yeah.
Where things are going to need robots to continue.
Yeah. Construction for sure has that problem, right? Where like the crazy anecdotes that I have and data for construction here are just like 40% of contractors are over the age of 50.
I know.
Right?
Oh my God. And new ones are not being trained.
Right. So
because everyone went to college and didn't want to go to blue collar jobs.
Right.
Which now we need so many more blue collar people for everything.
Right. In North Carolina, there are 3 contractors who can do electrical work that are licensed under the age of 30.
Wow. That's the whole state?
That's the whole state.
Holy cow.
Yeah.
That's wild.
Yeah. So there has to be automation, right? Like, and one way to think about it is that automation is just taking this old construction problem and making it sexy. Because if you can do it with a robot, it's hot. And like doing it by hand, well, let's say it's not.
Yeah. Well, I mean, but it lets you, there's so many exciting things about doing it with robots. Because one, the robots get better and better. It's like you can become a bit more of like a technician for the robots. Right. I don't know. I think the jobs will be changing.
Definitely.
For all of this.
Definitely. Yeah. And then, there are labor shortages on the job site as well. Like on X recently, I saw somebody post they expected 27 framers to show up for a job and only 3 showed up. And like that's part, like that's just the way contractors are, right? Like they're a very mercurial bunch. But then also like the political climate is also not great for the contractor, right? Like the official numbers are that 30 to 40% of contractors are undocumented. Our experience is more like 90%.
Holy cow.
So there is kind of this, a very interesting political aspect to it. That will I think demand more automation, more robotics.
Yep, that's just what I'm saying. Yeah, because it's the solution. We can automate ourselves into a better situation.
Right.
I do think there will be, I suspect, a wave of blue-collar workers.
Yeah.
Because plumbers are making $300K in the Bay Area, say.
Yep.
It's like they're making more than some software engineers.
Yep.
And I think we're seeing that kind of everywhere, or a lot of places anyways, that it's like a lot of these jobs, it's so scarce that you have a competent person that they can command a wonderful wage. And so that's driving people back into it, which will start to correct, I expect, in the U.S. Specifically, because we're relatively young demographically.
Right.
And
I think
still will be tough.
I think you're right there. It'll be a little bit slower in bigger cities because they tend to be more unionized and have a lot more requirements on, you got to apprentice for 7 to 10 years or something like that, right? And so that'll slow things down. But on the flip side, unions are also very good at adopting technology quickly, because they have to be able to like demonstrate like, hey, our higher wages provide more value. Right. And so we actually were really concerned about unions at first, but what we found is that they're actually pretty interested in adopting technology.
That's cool. Yeah, one of the companies that I talked with a while ago was Canvas, and they're doing robots for drywall.
Yep.
And they work very closely with unions in California.
Yeah.
Last I talked to them. And that was very interesting to hear. Are you guys doing any similar work with unions, or how are you guys working with or thinking about unions?
Yeah, unions aren't a big thing in the Southeast in general, so not terribly important.
And you're in North Carolina.
Yeah.
As you were saying, Durham.
Yep. So we're not terribly concerned. They just don't exist here. In other places, it's definitely going to have to be a conversation. But I think like Kevin from Canvas has demonstrated like the right way to approach unions and automation, and just like show that like, yeah, this is a tool, and just like all tools, craftsmen should use them.
Yeah, totally. Especially like for Canvas with drywall work. One, the labor shortages are intense there. And 2, the people who do it get like unbelievable repetitive stress, shoulder injuries, because they're just holding a sander and it's like finishing the wall, and it's just super, super difficult on their body. So they retire quickly from that kind of job.
Yeah.
So that makes sense for the union to really want to help them. And I would bet that it's similar for a lot of jobs. Like you were saying at the beginning that the injury rate is quite high, or accident rate, because like saws and stepping on 2x4s 1 floor up or more, this kind of thing.
Yep.
So I would bet that this would be a big benefit. So you guys have 27 homes. You're going for your Series A, so you're looking at scaling more.
Yep.
What do you think the future is going to look like for you guys? Like kind of draw it out for me, because I think like my impression is the last, like getting to 27 homes now, or getting to 27 homes has been kind of like a proof of concept. You've gotten it working. You're now making efficiency gains. Yep. Tell me how we go forward from here, and what do you think the timing, and what do you think the bottlenecks are, and everything?
Yeah. So forward is kind of along I think, three fronts. First is continuing to push on efficiency of robots. Second is adding more value to panels, right? So if you think about what can be prefabbed, the biggest piece of that pie is what we're already doing. That's about 20% of the cost of the home, right?
Is that factoring in labor?
Yeah,
20%.
Yep.
Oh, okay.
Yep.
So if you remove labor, if you just look at, but I guess that's the fair comparison for this. Okay, so that's 20%.
Yep.
I guess finishing takes a lot of it, like the finished parts, or I don't know.
So like roughly 20% of it is lumber, framing. And then the next two biggest chunks are actually plumbing and electrical. And so we have the ability to help them a lot there, in that we can route plumbing and electrical.
Oh, I like that a lot.
We can save a lot on copper. Copper is expensive. And then actually plumbing and electrical are the number one causes for framing failures when it comes to inspection. Because if you're drilling a hole through a 2x4 to run a pipe, the hole saw, if it walks a little bit one way or the other,
compromises the integrity of the structure.
Right. Right. And so being able to A, route it, and B, cut the holes very precisely makes their job easier. And then, I think there is kind of an interesting, 18 to 24 month problem of like, do we start to wire it in the warehouse? Right. Like
that would be so cool.
Right. And there's some interesting things there.
Sounds really hard. I imagine a lot of hard problems around it because they're deformable materials. I know they're pretty rigid, but still.
Right. And then
that motion planning problem,
that
would be much harder, I bet.
Right. And then the kind of like third area that I think is really important for us is we'll be pushing a lot on learning from demonstration, because as you expand into more and more of the house, things get more fabric-like or more squishy. And there's a ton of experience locked in craftsmen that if we can get them to demonstrate it, we can get the robots to do it.
That's really cool. That's a nice long-term perspective.
Right. So like a really early thing for us to tackle is actually insulation, right? Insulation is kind of fabric, right? When it's made from fiberglass, it feels kind of just like a big blanket. Being able to put that in, it is not a straightforward, like just a motion planning problem.
It's a very difficult compressible surface, and you have to do it just right and not have it overlap and stuff and whatever else.
Right.
Okay. Yeah, a lot of very cool problems and a lot of high potential use cases that sound like they leverage what you already have pretty well.
Yeah. I think one of the key things for us is that by tackling framing first and doing that in a warehouse, we really set ourselves up because everything else builds off of framing.
Yeah.
Right. And so we can leave ourselves kind of cookie crumbs where necessary to help future problems.
Yeah, super cool. I would say like the super low-hanging fruit to me that adds a lot of value is just cutting those holes for pipes and wires right as you're doing it. That's like, I can't imagine that's that much harder because you could just drill it while you grab the piece of wood you want, you drill the hole through it, and then you go place it where you want, and that hole is there now. That to me seems super, super exciting. And then all the other things are very, very cool as you guys grow as a company.
Yep. Yeah, the holes are like our number one requested feature right now. We don't get a lot of requests from the job site. They tend to usually just say everything's great. But that's one that we've gotten.
Hell yeah. Okay, very cool. So tell me a bit more about the construction space in general. Because a lot of people, I did a poll on X a while ago, and like it was bonkers. It was like 90% of people that are in the audience are interested in starting a robotics company at some point, and like 25% already had, or something like bonkers.
Yep.
So tell me about the construction space from the perspective of an entrepreneur. What are like low-hanging fruit, lots of opportunities?
Yeah.
How do you think of it?
Yeah.
Like, it's an exciting space, and I don't know too many robotic startups that are going in, and I think there's a lot of low-hanging fruit, probably.
Yes.
But what do you think?
Yeah. The way that I think about it is threefold. And it really ties into like, well, why is it awesome to work at BotBuilt every day? For me as a CTO, there's an endless number of problems, right? Like, and for me, that's really exciting. For some people, that's overwhelming.
Super fun.
But like, I'll solve this problem. There'll be another one.
Yes.
And it's because for the last 70, 80 years, there's been basically no innovation in construction. So you're 100% right. There's a ton of low-hanging fruit. Where strides have been made, they're typically made in high-end commercial, where when you failure means losses in the hundreds of millions of dollars. We haven't seen a lot of innovation in homes because if your home goes up in $10,000-$15,000 in price, whatever, your mortgage goes up by $10 to $50 a month or something like that, right? And so you don't really like, the kind of American consumer has been boiled like a frog as the prices keep going up because there's not really anything pushing it down. And so the result is that the U.S. is short homes, about
tons,
4.5 to 5 million homes. And we're not building them fast enough to catch up. That problem's getting worse.
I wonder how it will work with the baby boomers moving into retirement for everything. And if they'll move into like condos and free up their homes, or pass away and free up their homes, or things like this. But yeah, there's a huge home shortage, and so many people are just moving into apartments,
right?
Which is really interesting. And like, if you live in many big cities, it's just absolutely prohibitive to buy a home,
right,
for this kind of thing. So you're taking a bite out of that huge problem. Or I guess the 4.5 to 4 to 5 million.
Yeah.
Does that count people that are in apartments, or is that just, how do they get that number? I don't know if you know.
Yeah. There's like 3 or 4 different people that work on this problem. We know Stephen Kim, who's a economist at Evercore, if I remember correctly. He's just down the road here in Raleigh.
Cool.
And there's a bunch of ways that they get at this number. And I don't remember any of them off the top of my head. So
that's okay.
But it's
a huge group.
Right. The cool thing is that he actually releases a report every year on the state of housing. And just looks at
that's awesome.
Like latent demand, all sorts of various technical aspects. He's doing it from like an investor standpoint.
Yep. And so with this huge shortage of homes, that pushes up the price of all the other homes, making it even harder for people to buy homes.
Right.
Then, so you guys are trying to increase supply.
Yep.
Which will make it so that costs come down, more people can be in homes.
Right.
I really like the mission. I think, like, I've been a homeowner now for almost 3 years, and it is glorious. I absolutely love it. Like, the best thing is sitting in the backyard and everything.
Yeah.
But go ahead.
It's actually pretty interesting because I bring this up because not a lot of people believe this. More supply will drop the price down.
Totally.
And there's a number of people who don't believe this, but Austin is a great example of a city that
I was still going to say if you didn't,
that has massively increased its housing supply and has seen rents and mortgages drop by 15%.
Totally. Yeah, we bought a house right around that time, and we're in San Antonio, and it went through. San Antonio is like an hour away from Austin. We saw the same thing. And then it's just amazing. It's like market forces working, because you see the prices rise up because they can't build as fast as the demand is growing, because everyone has the internet and everyone decided to move there all at the same time.
Right.
And then they build and build and build. And then years later, it's like the demand, or the the demand matches the supply, and then you see prices come right back in line.
Right.
It was just remarkable.
Yeah.
Like, oh, wonderful. I absolutely love that.
Yeah, so there's big technical problems. There's a big societal problem, right? Like if we don't solve the housing problem, there's going to be a lot of unrest, right? Like people, the American dream kind of really, really affects how a lot of people think about whether or not they're successful in life, right? And so you could have this big societal unrest if you have a whole generation that can't get into homes.
Totally.
And then the last bit is it's a massive market, right? Like it's $1.7 trillion in the US. And I want to drive a fancy car and have a nice house. So you put all of those together. I think it's
forces align.
I think it's a great place to build a robotics company. And there's so much to do. I would love to have more friends come and build in construction.
Hell yeah. Yeah, that would be awesome. One thought with you mentioned unrest from lack of houses.
Yeah.
One other thing is that if people don't have houses, or like space, it's harder to have kids because you guys are all on top of each other.
Right.
And like we need a big replacement generation coming up for this kind of thing.
Yep.
To just keep life going and make it so we have a good, strong consumption economy.
Right.
30 years from now for this kind of thing.
Yep.
Because a lot of advanced societies, you see, they just move, industrialize, and then they stop having kids and the birth rate plummets.
Right.
Like a lot of Europe, say.
Right. Yeah. When we moved to Durham, we had a tiny little 2-bedroom, 2-bath. Got 4 kids now. I now have a 4-bed, 4-bath. Definitely need lots of space for kids. Can confirm.
Oh, totally. Can confirm. Yeah. That's great. Let's see. So tell me about North Carolina, because I don't know too many. So I lived in Charlotte for a while. I really loved it. But tell me a bit about Charlotte or North Carolina as a place for you guys as a robotics company and being in the Southeast in general.
Yeah. As a robotics company, where we're located is actually, I think, deeply underappreciated. They call it the Research Triangle, right? Basically Durham, Chapel Hill, and Raleigh. In that triangle, we actually have the second highest number of computer science PhDs. We're only beat by the Bay Area.
Wow.
And like people are like, no, that can't be true. That's that. Blah, blah. Red Hat, IBM, Cisco, Lenovo, Epic Games. There's a whole bunch of smaller companies that have spun out of that. And then there's a bunch of biotech, and so we see.
Oh yeah, that's what the area is known for,
right?
For sure,
right. But we also see a lot of surgical robots because of that as well. And then you add Duke and NC State have wonderful engineering programs. I went to Duke for my PhD, so like I guess I'll begrudgingly say UNC is also a good school. We actually just made our first UNC hire, and he is absolutely crushing it. So
hell yeah,
it's great to be in kind of this area where I can have a big house, lots of kids, and start a robotics company. And that's all very affordable, right? Like it's not, I'm not getting crushed by rent in San Francisco.
Yeah. Yeah. It's crazy. My house, when we bought in like the housing peak, when everyone was doing it, the mortgage on my house is the same as my studio apartment in San Francisco. Just before moving here.
Right.
And that price has increased since it was like COVID discount for this kind of thing.
Yeah.
So bonkers.
Right. And then the Southeast as a whole, like the Sun Belt, is growing. Everybody's building houses down here. So it's a wonderful place for a construction robotics company. And then there's just this really weird happenstance, where Durham, where we're located, has become kind of a construction tech hub. There are two other construction tech companies, both doing really cool things. Planted is down the road. They're building plywood sheets from grass, and the cool thing there is that it's a very,
I don't know what that means at all.
It's like a very particular type of grass, but what it boils down to is it's not as susceptible to mold growth.
Huh.
It's a couple of SpaceX guys that rolled out of SpaceX and decided to build a greener, safer, cheaper building material. And then Hierarch is also down the road, and they're doing like they want to make it so that way you can design your dream home from your house, right? Like it's just building out kind of the video game aspect of like designing your house.
So cool.
The three of us, it's been really cool to just be surrounded by other people who are thinking about how to change construction.
Hell yeah. And also makers and doing the good problems and everything.
Yep.
That's great.
Yep.
Hell yeah. So if you had to start over or say advice to a young founder, what do you think? Like, what would be some really good things to communicate to a younger you?
Yeah. Yeah. Younger me.
Or earlier you, I suppose.
Yeah. I think, like we came to the teleoperation driven development, partway through.
Iteratively.
Yeah.
Mm-hmm.
And I like that would be the biggest thing is start with that as your formative paradigm. And then, honestly, like just don't talk to SaaS investors. They're just wasting your time, right? Like a lot of them will totally just like, they'll say they're cool and then like, oh yeah, we do hard tech, right? Like that's a cool thing to say. But like if they haven't made a robotics investment, like just don't expect them to, right? And then I would also like upweight CVC, right? So like we have a lot of strategics that have helped us.
What is CVC?
Oh, sorry,
what is that?
Corporate venture capital.
Oh, yeah, totally.
And at least in construction, it's been massive for really understanding more of the nuance of all the particulars in this field.
Totally. And you're finding good partners and they're opening up a lot of doors, I expect.
Yeah. So those are kind of the big areas that I would think about. It's and the last thing I'll say, founder market fit is ridiculously important, and maybe it's just underappreciated from my perspective, but I don't hear a lot of people talking about it anymore.
What is it?
Yeah.
What do you mean? Founder market fit?
Yeah. So like, if
like finding market fit?
No. Like, you as a founder, do you fit with the market that you're trying to sell into? Right.
Oh,
and so
I don't hear this about ever, basically.
Yeah.
So that's a great point.
Right.
Okay. Yeah. Tell me more.
Yeah. So like the idea, one way that BotBuilt has been described by outsiders is that we're white collar workers, with a blue collar attitude, right? And so that lets us engage in construction, right? Like this is probably the longest I've gone without cursing for several days. Right? And
you didn't have to do that.
I know, but like I don't know. The kids might watch. So
yeah. So funny.
But like it, there's superficial stuff like that, but there's also like, do you share values with your customers? Right? And if you don't, maybe you don't want them as customers, right? Because it can be really hard for you to have any kind of customer empathy, if you're not like, if there's not some kind of value alignment there.
How would you know about that? I guess looking at your values, but I do think it's also very easy to delude yourself into something that seems to be lucrative, where you're like, oh, I could be interested in that, or I'm sure I'm interested in this altruistic purpose, even though it doesn't align with who you are and what you're actually interested in. Like, how would you find that? Because that seems like a good introspective challenge that I think a lot of people will struggle with.
Yeah, that's a good question. I mean, it's just what I gravitate towards, right? And so like I enjoy hanging out with construction people. So that's kind of how I
That's a simple answer that I think is kind of it.
right. Yeah.
Yeah.
Like you know, it's just yeah, there's just something about the market that you want to go into that you find interesting or fascinating, because at the end of the day, like, it's going to be deeply frustrating, right? Like,
Totally.
there are so many things that are going to go wrong, and so many people that I'll butt heads with. Brent, our CEO, is amazing at being friends with everyone. So like as a founder, like, you just have to, like, what's going to get you through whatever that frustration is.
Okay, I like that a lot. I have not heard about founder market fit. I think that's a really good idea, to pick a customer or pick some group to work with that you really like anyways. Because say you hate the values of one group, like you find it silly or something,
Right.
and go and try to work with them, and now it's like your startup's going to take 10 years, and so now you're interfacing with this group the whole time. It's a really easy way to get burned out,
Right.
and not do a good job. Whereas if you really like the values of them, then you're going to enjoy hanging out with them. You're going to enjoy trying to understand their problems. And you guys will probably both be more open to working with each other. Like, they'll try your thing and they'll let you in on good feedback and not sabotage your device or something like this, which might occur.
Right.
If they really dislike you.
Right. Yeah. 100%.
Hell yeah. So looking forward, I know that it's hard and you pointed to 3 things that look really exciting in the future of BotBuilt. But like, say 2 to 4 years from now, where do you expect you guys will be?
Yeah. We'll be on site. 100%. Like, I think for us to capture ever more value and to provide ever more value, we have to get out of the warehouse. And we, like, very specifically chose to begin in the warehouse because I knew just enough about lumber to know that, like, it was going to be painful to learn how to do it. And I wanted to do that in a controlled environment. But to really make an impact, to fundamentally change how construction is, we need to get onto the job site.
That's awesome. Hell yeah. Any thoughts with, like, size of the company, number of houses deployed? And these can be like, because obviously none of us know the future, but like, your current rate of growth seems amazing. And I suppose if a fraction of that is kept over the years, it'll be quite impressive where you guys get. But looking out in the future, any ideas around that?
Yeah. So right now we have 3 robot teams that are producing all of our houses. The robot team is just a pair of industrial arms that work together. I think in 3 years, we'll have, call it 150 to 200 teams.
Holy cow.
Yeah.
That'd be amazing.
And we'll have deployed with a whole bunch of franchise partners, right? Like, we can't own the US just by ourselves, particularly in construction, where so much of the sales is like, well, my dad knew his dad, right? It's a very relationship-based business, but we can make them more efficient and let them focus on what they like doing, which is sell me. And so we're actually doing our first deployment this summer to Florida.
So out of North Carolina, you're saying?
Yeah, so we'll have a bunch of teams set up down in Florida, and that'll be kind of the beginning of this franchise opportunity.
Hell yeah. And the start of, like, remote scaling, which is its own hard problem.
Right.
And that will be amazing. Because, once you nail that, then you can go everywhere.
Right.
Come to Texas, go everywhere else.
Right.
Hell yeah. Okay. Wrapping up, what do you hope our watchers and listeners take away from this interview?
I think there's 2 things. One is that the future of construction is automated. And second, that working on robots that work in construction, it is a really interesting problem that can help a lot of people, right? Like you can do really good things for people and work on really interesting technical problems.
Mm-hmm. Yeah, I think it's a super exciting space. All right. Hell yeah. Thank you, Barrett.
Yeah, thank you. Great to be here.
All right. Bye, everyone.